A warm welcome from my side. This talk is about AI for innovation, and it's based on an analysis that we did for a ministry, the Ministry of Innovation in Austria, in the context of designing a new Austrian AI strategy that's to be published this summer. I'm not sure it's going to be published because, as some of you may know, we had some troubles with our government, but should we have a government, then probably also the AI strategy is going to be published. I should say one word about myself because it's relevant for the presentation. My background used to be, or still is, artificial intelligence. A couple of decades ago, I worked in AI. So today I feel like one of those professors that you may also know that look into current technologies and then say, oh, we did that 20 years ago. And that's pretty much how I feel about artificial intelligence, with the exception that today it seems to work better. So in that sense, it's different. This image is a piece of art presented at the MAC Biennale in Vienna. It's called Roboter, Arbeit, Zukunft, Robot, Work, Future. And it's called The Fragile Balance of Utopia. And the reason I'm showing this is because I'm sure many of you are aware of all those strategy papers, mostly from consultants, international consultancy companies, who promise all sorts of things for innovating by means of artificial intelligence. They draw pictures, utopian pictures often, and you probably ask yourself, well, are these utopian visions going to come true anytime soon? And I think what we need to understand is that there is indeed a fragile balance looking at those pictures, because on the one hand, I do not personally believe in general AI to come true anytime soon, but on the other hand, there is really a lot going on, and one result of the study that I'm going to present for me personally was that I was overwhelmed nearly by how many sectors are currently already affected by developments in AI. But before we go there, let's briefly look at what we did. So we focused on artificial intelligence for innovation as it's used in Austrian, mostly technology enterprises. We did expert interviews to better understand what are the companies really doing. And we selected the experts and also the projects in which they are involved by using a keyword definition of AI. I'm going to have another slide on that. And then we selected projects from research databases and did guided interviews. The project itself is much larger. The project itself was mostly an economic assessment at the level of the Austrian economic statistics. So I'm only going to present a very small part, but in the question section you can ask me about the rest of the project if you like. So as with any AI project, there is the fundamental question of what do we mean by AI, and that is a tricky one. There are at least three relevant definitions. One is to say AI is anything that's typically what humans do and what we are now trying to make machines do as well. This is not a very good definition because it's a moving target. So chess playing, I guess, is no longer AI because that's something that computers now can do. And then there are some other areas where computers are still pretty bad. A second definition would be to focus entirely on learning systems. So, for example, statistical neural network-based learning. And I have seen this used in practice. I think that's a definition that's also not a very good one because it excludes many other areas of artificial intelligence, such as expert systems, rule-based systems, which I think have, with some justification, already played a big role also in AI and innovation. So the third definition is the one we used. We used a topical-based definition. Basically, that means we look into what have historically been fields of artificial intelligence, and that is basically things like expert systems, neural networks, image recognition, video analysis, understanding of language, production of language. So these sorts of things that have been around for at least 20 or 30 years and which are associated with artificial intelligence. That unfortunately means that you have to look into all these fields, and if you want to, like we did, search in relevant projects in a large project database, you have to define keywords in order to find those projects. So we did that based on my own background knowledge in AI. That was not a particularly difficult task. So we defined keywords both in English and German in order to search through databases with innovative, mostly research projects of the Austrian Research Promotion Agency, for example, but also Horizon 2020, and identified lists of projects, which of course were about past projects, so that we could identify relevant companies represented in those projects. Now, coming to the AI technologies in these projects and also from the interviews, there is a broad variety of technologies that people use. It ranges from machine learning to, as I said, image and video processing, knowledge processing. It includes neural networks of all sorts, predictive analytics, but also prescriptive analytics, language generation, language understanding, even some more rare topics such as gesture language generation, image recognition, deductive system, knowledge graphs, that sort of thing. So it's really the full variety of AI technologies that people are already using in innovative systems and services. For which application areas, and here it becomes really broad. It ranges from I would say the more expected chatbots, which are probably borderline AI, to intelligent travel agents, human resource assistants, semantic search, trend analysis, threat analysis in cybersecurity. When we come to industrial automation and plant operation, there's a lot of optimization. Predictive maintenance is a big topic, but also video-based quality analysis, error detection, a lot of automation of complex manual procedures. Sensor fusion is a big topic. Then we come to video and image classification, where the processing of sound and images is done using these techniques which I've previously shown. Of course, big topic, autonomous operations, autonomous vehicles, autonomous operation of plants, increasingly important. 2 software-defined networks for various IT applications, optimization of IT networks, software maintenance, even anonymization in the sense of protecting people's privacy, for which people also use neural networks. So I think it's fair to say we see all sorts of applications. It really poses the question whether there is, an area where there is no AI involved. It's such a broad field, and as I said, these are things where AI is already deployed in Austria in innovative services. So, given this large and diverse field, the question arises: what are the barriers? And I think it's fair to say the number one barrier is qualified staff. So that, of course, includes IT experts. That's not new. We know that from other domains. But it was interesting for us to learn that even computer scientists, young computer scientists that graduate from universities may not have sufficient AI knowledge for the companies who want to do AI innovation. So I thought that was quite interesting. So it's not just AI specialists, it's also generalists, of course, software developers and AI experts. And then there was also, in the interviews, was quite interesting, there was a new job emerging. People said AI trainers. So these would be people who use existing AI tools, may have some base knowledge of AI, but basically their job is to optimize models using existing techniques and experimenting with data so as to generate innovative AI applications. But of course, again, difficult to find those people. Costs, it can be an issue, especially in the field of robotics. Hardware for robotics is very expensive. but also to create know-how on AI in-house was considered to be very costly. There are also often long development times, and more importantly, unpredictable development times, because as you may know, many of the AI technologies require a lot of trial and error, and that makes it quite unpredictable. It makes it also very difficult to manage the innovation beforehand, because you don't know how long it's going to take until you reach a sufficient level of quality. There is also an insufficient degree of information about AI in general, and this, for example, includes C-level executives. So they may have a rough understanding of what AI is and can do, but not a very detailed knowledge about it. Again, this can be a challenge for innovation management, because it simply means that it's difficult for those people to predict exactly what a system could or couldn't do. Which makes innovation management, I think, specifically difficult. The credibility of AI solutions, especially when we talk about neural network learning, is a big problem. It's also related to some unrealistic claims, for example, from consultants about AI, and then consequently disappointment. There are technical aspects which can be barriers, such as the lack of explainability in some models. Regulation can be an issue, for example, in the health sector, but also in technology sectors, such as, well, in the technical domain, where your machines are supposed to work reliably. And then there is this reliability is not only something that can be a barrier on the side of the people deploying the AI system or solution, but also at the side of the customers, who usually understand that they get reliable, predictable systems, and that may be different with some AI systems. And then a final barrier mentioned in the interviews was hype. Some of the experts were fearful that this current hype about AI may just lead to large disappointments in the future and may make it more difficult. So AI for innovation, I think what's specific about it is that when we talk about the innovation characteristics, it's not fully clear whether these are technology or application features. What I mean is, intelligence in that sense may sometimes refer to the underlying technology, or it refers to really the application, such as in natural language understanding, for example. And there is of course, there's a big confusion. It's not very clear. It's used everywhere. And I think we'll probably see certain maturity only in the next years, when maybe the AI techniques become regular computer science tools and methods that will just be used regularly. What are the drivers? People say what they are most interested in is automation, process improvements, also improvements in terms of resource efficiency, and that also includes cost, which of course means staff, but also some qualitative innovation that simply isn't possible without AI. So that's, for example, in the case of image understanding, image recognition, high-speed solutions which wouldn't be applicable otherwise. We see a broad range of promises. Again, this makes it very difficult to say if there's anything specific about AI innovation. But there is definitely, in terms of the method, something very specific is this trial and error approach that seems to be much more important with the development of AI systems than other systems, where at least for parts of the systems you pretty well understand what's possible and what's not, and with which criteria or not. But in AI, this is really difficult. And the final point would be the technical and historical dimension of data. I think this is a tricky one. For learning systems, such as neural networks, you may have a lot of data in your company, but you not only need the data, obviously you also need the expert who understands the data and also understands the historic dimension of that data. So that means you need someone who really understands where does this data come from, what are the sensors that develop it or have been delivering the data for the last 5 years. And they may have information that typically the expert in the domain may not have. So this is really an interesting dimension. It's a particular challenge for small and medium-sized enterprises because these experts may not be available, they may have changed, the sensor may have changed. So understanding the metadata is an added dimension, I think, and that's something that's relatively new and specific about AI.
6 more minutes.
Oh, great.
And you are already into the
Okay,
discussion time.
great, thank you. When we look at the domain that probably is most interesting from the point of view of the Austrian government also is this domain of engineering applications. So Austria is a country that in its industry has a specific strength in machining, in the automotive sector, also in aeronautics. And we found it very interesting that these seem to be currently the people innovating most or experimenting most with artificial intelligence. And the reason is that they simply have sufficient data available because the data is automatically generated. It comes from their embedded systems, which they usually log the data with. And they also have skilled staff. They have engineers, they understand what the challenges are, and they also have a competitive mindset in the sense that they want to create innovative systems and applications. On the other hand, they are also specifically challenged because they need real-time solutions, they need secure systems, they need explainability and predictability. So it's an interesting challenge, and we are going to see how this will be handled by SMEs in this area in particular. And I think that summarizes what I wanted to say. Thank you very much.